So welcome everyone um, to a presentation about Solidworks Fluency. So the goal of this presentation is to talk about how to better leverage Solidworks for design. We're going to go through that in several different ways. So first of all, hello, my name is Michael McNabb. I'm a student supervisor at the Jacobs Institute. I've been working there for about a year now. And I've been solid modeling and using SolidWorks for over 5 years now, and I've been teaching for 3 or 4 of those. And I initially learned through First Robotics. I was an alumni, and I'm studying mechanical engineering and business, class of 2022. Now, I took E26 as part of the mechanical engineering curriculum, and there were several problems that I had noticed with it. First of all, it's not adequately taught with a design focus. And at the Jacobs Institute for Design Innovation, that's really something that we should be prioritizing a little bit more. So the goal of this presentation is to kind of highlight some of the better, or some of the applications of SolidWorks in design specific ways. So that's kind of the goal here. We want to develop fluency within the SolidWorks environment and kind of make you more comfortable with the user interface and be able to more quickly and more efficiently work on parts and assemblies. You don't need to have SolidWorks to follow along here. This is, it's designed to be helpful for everyone, although we will range from beginner to intermediate level topics. And it'll help you kind of get more control over what you're doing in the software. So we're gonna start off with the basics. I don't know what your guys' skill levels are, but I'm gonna start from the basics and kind of build my way up somewhat quickly. I assume you guys have some familiarity maybe with what SolidWorks is, but if not, I'll go through it. So SolidWorks is a solid modeling environment where you can build parts, assemblies, components, and design anything you'd like, really. And there's 3 types of files. There's parts, there's assemblies, and there's drawings. I'm going to be focusing on parts and assemblies today. And I'm going to be going through some of the design steps as well. So usually in most of your parts, you're going to be going from reference geometry. So that's something like one of the planes or an axis or something that's not actually a physical manifestation of your idea. And then you're going to be making a sketch to add on that, and you're going to be turning that sketch into a feature. Now, as with most solid modelers, there's tons of ways to make every single part. If I was trying to make a cube, I could do a simple extrusion, or I could do loft, or there's a boundary surface. There's many different ways to do it. So I'm not going to be giving a comprehensive list of how to do everything, but I am going to be sharing some of the methods, tips, and tricks that I've picked up on over the years that I've been using the software. So I'm going to start by going through the user interface. First of all, I'm going to switch to SolidWorks. Can you guys see my SolidWorks interface here? I hope so. If you can't, someone please speak up, but I'm going to assume you can. Wonderful, thank you guys. So yeah, also at any point, if you have any questions, feel free to either unmute your mic and ask, or type it in the chat. I'll be checking that frequently as I can. So when you open SolidWorks for the first time, you're greeted with this home page, and here's where you can decide whether you want to open a new part or open an existing one. I'm gonna start by opening up a new part, and you're met with this interface. Now, if you've never used SolidWorks, this can be a little bit intimidating. There's a lot going on here. So I'm going to go through it step by step, some of the things that I wish I had been taught when I first was getting to learn the software. So there's several components to this. There's the command manager, feature tree. I'm going to go through each of these one by one as well. Starting with the command manager. This is going to be the root of, or most of your operations within SolidWorks is going to be stemming from the command manager. The command manager is this at the top of the screen here for most people, although you can drag it around and move it around. This is where you can choose what type of features and what type of components and other elements you'd like to add to your part or your file. Now, we're going to be talking about some customization as well, just to kind of make it more streamlined. You can customize almost everything in SolidWorks, and that means all of your toolbars, all of your command managers, all of your files, it can be very thoroughly customized. So the way you do that is by right-clicking on it. So if I go up here, right-click on Command Manager, you can see a lot of options. And this is where you can turn on and off other toolbars. So for example, If I want to have sketch tools, I can click on the sketch dialog box, and over on the right side here, there appears a toolbar where I can have all of my sketch features kind of in one place. And you can drag everything around by clicking on these little 3 dots or lines of dots here. You can kind of put them on the top here or wherever you really desire. Put this one up here. And you can turn on and off things as you want to use them. So if I don't need the sketch toolbar, I can just hide that. You can also reorganize your tools by holding Alt and dragging things around. So if I use reference geometry a lot, I can hold Alt and drag it around. And I can put it wherever I want it to keep myself organized. Next up is the feature manager and the feature tree. This is another place where you're going to get a lot of use out when you're working. This is on the left-hand side over here. Now, what this does is it gives you basically a history of the part or assembly that you're working on. So if I open up something, I'm going to open something that we're actually going to be making today, which is a 1, 2, 3 block that I finished. Basically, you'll be able to see a history of what the part is and all the different steps that were taken to make it. And we'll go through that. There's also an important feature that not a lot of people, or I don't think, is properly emphasized, which is the rollback bar. If you're in an assembly, someone hands it to you and you want to see how it was made, you can roll back the component to any point in time. And that's this horizontal bar underneath the feature tree right here. You can roll it back and undo a step-by-step process. So for example, if there are tapped holes that I don't need, you can roll back step by step and kind of see the process that was used to make this part. So I started with a boss extrusion, and then I went and did a tapped hole pattern on the top face, and so forth. Okay. Next up is the task pane. This is something that is a little bit more useful if you're doing some more visual type things. So this is on the right-hand side over here. You've got a number of different options here that you can use to customize your model. For example, if I wanted to change the appearance of this 1, 2, 3 block, I can go to the Appearances tab, and then I can add a color or a texture to it as well. So if I wanted to make it a red plastic, that's something I have control over as well. I can just drag a color on there. And then in the Feature Manager, there's a Appearances tab where you can actually adjust what that looks like as well. So I can right-click to edit the appearances, and you can change the color around of your model. This is not as important for functionality, but it can definitely help if you're making a render and you want something to look more professional or more accurate. Okay. So also, if you're in a drawing, there's a tab for the View palette right above the Appearance tab. I'm not in a drawing right now, so it's not going to do anything, but that's useful if you need to insert other part drawing views. Okay. Speaking of views, I'm going to go through the standard views that you have access to at any point within SolidWorks. So pressing and holding middle click, first of all, allows you to rotate and orbit around the model. It kind of spins it around in space. But if you're trying to work on a component, it can be difficult to line it up exactly. So that's where your standard views come in. If you hold Control and press the numbers 1 through 9, it'll take you to the standard views of the object. And if you are in a standard view, you can see on the bottom left here, beneath my axes, it says star front. It means I'm in the front view, or I'm in the back view, left view. And this is, up through 6 are the 6 standard facial or face views. And then 7 is the normal to, or sorry, 7 is the isometric, 8 is the front, and 9 is the normal to view, I believe. What the normal to button allows you to do is select a face, and then if you go to view orientation, normal to, it allows you to immediately go so that you're perpendicular to that face. This is extremely useful and is one of the most useful things that was not taught in E26 that really simplifies the design process. This especially helps if you're working on a complex model, or let's say I wanted to add something onto the chamfer. I could even go normal to that chamfer. So if I want to drill a hole through that complex angle, it's not a standard view. This just makes it a lot easier to do that. Now, how did I just get to normal view? Normal to right there. I right-clicked on it, and there was an option here, an icon for it. It says normal to. That is not there by default. That's something that I had to customize and add in. And that's going to be detailed, in just a second here. Next up, middle click. Like I said, you can use it to orbit around the model, but if you hold any number of keys, you can modify the functionality of this. If I hold Shift, then middle click will actually zoom in and out. If If I hold Alt, it will actually rotate the view around the plane. And if I hold Control, I can pan the view around like this. So this allows you to really have control over exactly what you're seeing at any given time.
Sorry, how did you do the pan view again?
Hold Control. Yeah.
Oh, okay.
So if you hold Control and then use the middle click button, you can pan around the view, and that can make it a lot easier to focus in on specific components. Also, scrolling in and out allows you to zoom as you'd expect. These are the default controls. You can change these all around as well. All right. Now I'll go through some of the toolbars that I use most frequently. I kind of already touched on this a little bit. If you right-click on the command manager, you see a list of all the toolbars you can open. The most useful one, the one that I use by far the most frequently, is the Tools toolbar. These are kind of the most frequent things that you're usually going to be trying to find within the Evaluate tab. And rather than going up to Evaluate, Measure every single time, you could just go up here and click the little measuring tape and say, okay, this is indeed almost 3 inches long because of the chamfer. If I wanted to find a face-to-face measurement, you click on two faces with the measure tool and it'll tell you the distance between them. Okay. There's also the mass properties tool here right next to it, so you can find out exactly how much this weighs. This 123 block weighs about 1 pound. It'll tell you that right here. And also, if you're working on a part or an assembly that you need to have a different type of unit, you can change that in the bottom right corner. At the very bottom left, or sorry, bottom right, it says IPS. You can click on any other unit or document unit and see what it would be in those units. So if I go to MMGS, then when I choose mass properties, it'll be in grams instead of pounds. Okay. Now I'm going to go through some shortcuts. These are things that really will speed up your time when you're making these parts. First, I'm going to go through some keyboard shortcuts. The most useful or the most frequently used for me is the S shortcut. If you press S at any point, it brings up a little shortcuts toolbar that's relevant to what you're doing at the time. So if I'm here in the assembly, I just without any specific feature in progress, then I can create a new extrusion here, for example. If I'm inside of a sketch, then I have access to all the sketch features. So I can make a circle here, and then that'll allow me to switch between smart dimension. It really is quite quick. In addition to that, you can also hold right-click and move to any of the 4 directions, and a circle of your most frequently used tools will appear. So this will allow you to cycle between your line tool if you just hold right-click and slide to the left, rectangle on the bottom, circle on the right, and smart dimension on the top. Smart dimension is the name of the tool that automatically tries to determine which dimension is best for the feature that you're trying to define. You can also press the drop down if you want to use more complex dimensions. For example, if you want it to be necessarily or horizontal dimension, this will allow you to do that. Okay. You can also, if you have something selected, the icon will appear right next to your cursor. And if you swipe up again, you'll be able to cancel that. Okay. So we went through that S shortcuts menu up there. Next is F. This happens a lot if you're working on big components or you get zoomed out by mistake. If you press F, it'll fit the model to fill your screen. This is really useful, especially if you're working on, sometimes there's some bugs within SolidWorks that cause you to select something very far away within an assembly. If you move a part around, it can get pushed very far into the distance. And if you press F, it'll zoom in and you'll see, okay, where is that part that I was looking at? That can be very helpful. Okay, we went through right-click and drag for quick tools. If you're inputting a feature, this is something that I'll show in more detail in a little bit, but if I'm, let's say I actually go through this extrusion, if I had a circle here that I was trying to extrude, if these settings are correct, right-click and go to OK is faster than going up to the top right corner. And if you're inserting parts, you actually don't even have to go through the menu to OK. The right-click will automatically default to confirm. Okay. I'm going to go through some other customizations that I've made to the UI and just to the design process that may be helpful. So first of all, as you may have seen during this sketch that I was just making, if I try to create a new entity of any sort, so let's say I try to make a circle. First of all, I'm going to go normal to the sketch plane so it's more clear. I have the option to type in the size that I want immediately. So I want a 1/2-inch circle and it creates the dimension for me. This is not enabled by default. You have to enable this, and I'll show you how to do that. Oops. Yes. So you go to the options settings over here, and then under sketch, there's an option midway through enable on-screen numeric input on entity creation. This is immensely helpful and really saves a lot of time rather than having to go to the dimension tool every single time and input that. Okay, next up, another thing that's enabled by default that can be useful sometimes, but I find it distracting personally, is closed contours. I'm actually going to go to a new part to demonstrate this one. And I'll talk about what those templates mean in just a minute too. So if I'm creating a sketch, let's say I'm making a part with several different features in it. Maybe there's a circle here, there's a circle here. No clue what the part might be. By default, what it looks like is this. There's a setting that shades in all of the sketch contours like this. So if you're doing a more complex line structure and you don't have it quite completed, then it'll tell you. And that's what SolidWorks recognizes. But as soon as you close a contour, it shows up as a dark shaded region. Now this is helpful sometimes if you're trying to actually make an extrusion or something like that, versus if you're trying to do a thin feature. A thin feature is something that depends only on a line in a non-closed contour. So it uses the line basically to make, I guess I'll show you. If I just use this feature right here, you can create an extrusion from a thin feature like so. There's a checkbox here that allows you to kind of just make something that depends on the edge but not the interior volume as shown. So this can be useful if you're making a shell or some abstract shape. Yeah, so that's the closed contour. I personally find it distracting if I'm working on a flat sketch most of the time, so I turn it off. Again, to access that, it's in the top bar, Tools, Sketch Settings, and then Shaded Sketch Contours. If you're in the Sketch menu, you can actually turn that on and off. I'm not right now, so I'll edit the sketch and turn that off. Okay, I went through the normal to view and some of the more other shortcuts. Another thing that might be useful is equations. This is something that also I don't believe is covered within E26, although it might be now. If you want to define a part or an assembly based on global variables, or if you want to do some mathematics inside of a sketch or dimension, for example, you can do that. There's an equations tool within SolidWorks. I won't go into all the specifics of how it actually works, but there's a tab up here that allows you to define a global variable, let's say width, and I can create a value of 10. And then if I want to define something with width, I just smart dimension, and then when I type the value, I type equals width. And then it'll be 10 inches. And you'll also see there's an equation symbol next to the dimension here. So now if I go into the equations dialog box, I can change the value of width to 11, and it'll update the sketch accordingly. This is extremely useful if you're doing a lot of design changes last minute. You can just have everything dependent on that one variable. When you change the variable, it'll allow you to very quickly see the results in your assembly or part.
Do you know how to do that across multiple parts?
There is a way to do that. It gets a little bit more involved if you're in an assembly. Usually what I do is, I'll get to that a little bit later in the assembly section of this presentation actually, but usually what you have to do is create a sketch in the context of the assembly and then make the parts in that assembly dependent on that sketch. So it's a little bit of a workaround. I wish there was an easier way to have global variables apply assembly-wide, but that has worked for me in the past.
Okay.
Yeah. Okay. Yes, I think we're done here. Now I'm going to go through just a basic part. I'm going to make a gusset that we're going to use later for demonstration. So I'm actually going to start with this sketch because it's going to be based off of this. I'm going to make a 3-inch wide by, let's say, 2 inches tall gusset. This might be to connect some sort of components, maybe aluminum channels. So another thing that I will mention is that there's several different aspects or several different parts of sketches that I want to bring attention to. When you first draw any sort of entity within a sketch, it will be blue. And this means that it's underdefined. And generally, I try to avoid having underdefined entities within my sketches just because then you can click and drag them around and that's not precise for if you need a specific tolerance dimension. So instead, and a way to tell if your sketch is fully defined or not is on the bottom right-hand corner. There's a box that says underdefined. So if I go through and I actually define this, this sketch entirely with what I want, then it'll turn from underdefined to fully defined. So let's say I'm making a, I don't know, a 2-inch bar or something. Now I'm using a combination of both dimensions and relations here. Relations are sort of like dimensions in that they allow you to flush out the positions of sketch entities, but they aren't like dimensions in that they're dynamic. A dimension will not change. This will always be 2 inches no matter what. But what I did here is I made this line that I've selected here collinear with this bottom line, meaning that if I change this to 3 inches, say, it'll automatically update. Now you could do this, that was a fairly simple example, but you could do that with midpoints as well. So rather than having a part or feature defined relative to one edge, you can have it centered within the part easily. So I'll actually do that next. Don't want to do that. All right, I want something that is not symmetric for this demo actually. So I'm gonna change this around a little bit. So you can delete relations by selecting the line and then it is able to be adjusted. So now I'm gonna make an L gusset. This will allow for you to join 2 bars at right angles. Now, there's a lot of ways to do this, like I said. I'm deciding to use the trim entities tool so I can just make a simple L shape like so. And then I'll close the contour here. And this is an example of where it's useful to actually see if you have closed sketch contours. The reason why I'm doing, by the way, multiple steps within one part is to save myself time later. And I'll show you exactly how that's going to work. But you can see that now I actually can see that there are 2 sketch contours here. And that's good. That's what I want. Okay. Let's make this 1 inch and this 1 inch. If you miss, it'll ask you if you're trying to over-define the assembly, which I'm not. If you have too many dimensions, then the SolidWorks can't find out a way to actually solve for the dimensions that you're looking for. It says the entire model is invalid. And as you can see also now, we've fully added dimensions as needed, and it no longer says underdefined in the bottom right corner. It says fully defined. That's what we want. So now what I'm going to do is just exit the sketch. And it still thought it was a thin feature, so I'm just going to delete that. It's not a thin feature anymore. But we can use this sketch to create multiple features. We're going to start by extruding the entire thickness of the metal that we would use for this. And this is where the feature tree comes in handy. If you're extruding from a sketch that you've already created, the feature tree is available right next to the feature manager on the right. You can select the sketch here. And because we have multiple contours, we're going to have to select which ones we actually want to extrude. So here I want to extrude all of them to be, I don't know, 0.125 inches thick. Let's say 0.25 inches thick. And then hit OK. And now I can use the exact same sketch. Still exists, but I can use it to finish the rest of this part too. I can use extruded cut, select the same sketch right here, and then from there I can select a contour that I want to use. And I want to use this contour. and I want to cut into the top half of this part. So I'm going to select, you can select different aspects of each feature as well. So I can choose, okay, do I want to go from where the sketch plane is, or do I want to go from another location? I'm going to go from the top surface here, and then I'm going to choose how far do I want to go in. I want to go 1/8 of an inch in. And there was a good example of what I was trying to show earlier, and it went away. If you input the dimension right as you're doing this, your mouse will show an OK symbol next to the right mouse button, and you'll be able to just click OK and skip this step. But yeah, now we have a finished gusset. Now this is actually symmetric because it's square, but let's say it wasn't, and actually can change that pretty quickly. So now this is no longer a symmetric part. And if I wanted one of these, I'd want to sandwich it over 2 parts. And if that, I'll show you how that'll work in a 3D model in just a moment. But I would have to make a mirror image of this part naturally, and that would require going through the entire process that I just went through again, but with this channel on the other side, and that's a waste of time. So there's an easier way to do it, thankfully. After I've saved this part, gusset, let's say left. After I've saved this part, I can actually go ahead and just mirror the entire thing. If you go to the features tool here, there's a mirror tool. You pick a plane. I'm gonna pick the right plane, and then pick the body that I want to mirror in the solid bodies tool, or in the solid bodies window. And then I want to make sure I unclick the box merge solids. And what that'll do is it'll create an overlap. It'll create the original one, which I'm going to hide, and then a mirror image of it. And this is already finished. What you can do from there is just save this mirrored component as an external file. And I'll get into this in more detail in just a minute. I'm totally skipping ahead of the presentation, but that allows you to really save a lot of time with mirrored components. And you can do this within assemblies as well. Are there any questions about that?
How do you create a new solid body again?
Yeah, good question. So how you do that is when you're at any step of a feature creation process, so for example, the mirror, there's an option here for merge solids. And what that will do is it'll combine the feature that you're about to create with one of the existing bodies. If you want to create a new body, you just uncheck that box and it will create it in a new body. Okay. Yeah, so that's a gusset. Now I'm going to go in a little bit more detail about some of the finer details of best practice for part design. And this will kind of help us save some time. So the reason why I was able to do a mirror image of that gusset is, well, partially because it was centered in the planes. When you create a part, there's 3 fundamental planes that are given to you. There's the top plane, the right plane, and the front plane. And if you design your part so that it's centered among those planes, then you could use symmetry to your advantage when designing the part. So for example, if you had mirror image of a complex part, you don't have to do all of the steps for both sides. You could just do them on one side, then mirror all of the features from one side onto the other. That'll save a lot of time. This also works for circular pattern. If you have a complex circular part that you want to make with lots of, rotational symmetry, you can just make one portion of it and then copy it around in a circle. Now, the next thing I want to talk about is critically use-driven design. This is something that I talked a little bit about, but not directly just a second ago when designing the gusset. And I'll show you what I mean. When I look at the sketch here, there's many different ways I could have defined these dimensions. I defined the width here, and then I defined the channel width. So this is the flange on the left here, and this is the channel width in the middle. And the reason why I defined these as opposed to defining the width here is because this dimension doesn't matter to me. I don't care if this is 1.875 inches most of the time. I care that the part that I'm aligning this with will fit into it. So that's just something that's useful to keep in mind when you're designing parts and assemblies. Okay. All right, now I'm going to go into more detail about sketches. Sketches have 2 fundamental parts of them. There's the actual sketch and everything inside of it, those entities, and then there's the sketch plane. The sketch plane is what SolidWorks actually uses to determine where the part exists. So I'm going to exit out of this, create a new part. So when I press the sketch button, I get to choose which plane to create the sketch for. I'm going to pick the right plane to start. And let's say I make some sort of part. I'm going to make a circle, say 5 inches. Doesn't really matter. But what you can do here is if you change the sketch plane, first of all, you can change the sketch plane by right-clicking on the sketch, edit sketch plane, and it'll project it into whichever plane you want. So if I wanted to project it into this top plane, I hit OK, then the circle gets translated into the top plane. If I go into isometric view, here it is now. Here's what it looked like before. You can very easily tweak around your sketches by moving around, by changing the sketch plane. That's something that I don't think is covered in enough detail, because you can really use that to save a lot of time in your designs. Everything else, we've talked about a little bit. Like I said, I skipped ahead earlier. Sketch entities are everything else inside the sketch. That's all of your lines and geometry that you're drawing that you actually want to turn into features. Now there's, without going needlessly complex, there's a few different types. There's all of your different types of geometry that are available in the top left here. You can create slot tools, which have special features. You can create arcs, circles, rectangles, splines, that sort of thing. And then there's also features that aren't really sketches. So for example, the text. If I wanted to have text going around this circle, I could do that. But if I hit save, this is not the same as the circle here. This text feature cannot be used to directly create features. And there is a way to get around that. I'll talk about what that is. You have to dissolve sketch text, and then it actually turns into a whole bunch of line segments that will allow you to create your geometry that you desire. Just a little side note there. Okay, I talked about this a little bit, defined versus underdefined components. Everything that's fully defined will appear black. Everything that's underdefined will appear blue by default. And you will usually want your sketches to be fully defined. Not always. There are some times when you want underdefined parts. If you are using like something that moves, for example, you can use sketches for your advantage there. Another thing that, just a side note, the selection tool. If you use your mouse and drag, if you drag from left to right, it's blue. If you drag from right to left, it's green. These actually do different things. If you drag from left to right, it will only select things that are entirely included within your selection. So that would mean that this text is selected, but not the circle and not the dimension. But if you drag from right to left, it selects everything that the selection box touches. So it will select the dimension, it will select the circle, and the text features as well. Yes. Okay, I talked a little bit about relations. Relations are immensely useful. I'll show that in a little bit more detail right now. If I'm creating some sort of rectangle here, and I want to have a line going down the middle of it, or even just a circle down the middle of it, there's a few ways I can do that. I can define it so that it's the distance from the edge, and then if I choose the dimension of this side so that it actually looks like it's about half and half, that would work. But then as soon as I change this to be 1 inch, then this doesn't move with it, and that's no good. We don't want that. So instead of that, we can use relations to our advantage here. There's a few ways we could do this. If you right-click on a line segment, you have the option to select the midpoint, and holding Control allows you to select another point, and then you can add relations between those 2 points. So if I add the vertical relation, then no matter what, this is going to be vertically aligned with the midpoint of this line segment. So that means I can change this to 2, and it'll move with it. And that's really useful. You don't want to have dimensions there because it's just a waste of time and energy trying to find where it goes wrong if you have to change dimension, which happens a lot. Okay. Next up, I'm going to go a little bit more detail about bodies. There's a few parts or a few components of parts, as confusing as that might sound. There are sketches, there are surfaces, there are features or extrusions, solid things essentially, and then there's bodies. Bodies are the actual, if you build a whole bunch of features together, that one solid body is what you get. Now, there's several things you can do with bodies that a lot of people don't teach about. For example, you can intersect them and you can create useful things out of the intersections between those bodies. So I'll open up an old file that I've created a long time ago, just to show kind of what you can do with this process. So this is a part that I made a long time ago. It's the intersection of three spheres. So what I did here is I made one sphere, and then I made another sphere, and then I made another sphere, and one more, such that the four form this intersection in the middle. And using the intersect tool, which is available in features and right here within your dialog box, you can take a whole bunch of solids and you can find out where they intersect each other, and you can make really interesting shapes out of those. So I'll show you what it looked like here. In fact, I'll just delete it and do it again. So another thing that I should mention is that when I created each of these circle or spheres, I did not combine them. They're all separate bodies, and that's necessary for the intersect feature. Intersect, you select your bodies that you would like to intersect, press the button, and it finds all of the separate sections that are intersected, and you can click on them if you want to hide them. So with this, you can get some really interesting shapes. Can be very useful if you're trying to get things to fit together more properly. And this is how I ended up making this piece right here. And then you can choose if you want to keep or invert the selection as well. Something that you probably won't use a lot, but if you do need to use it, it's helpful to know about. Okay. Next thing I'm going to talk about is templates. This is something that's really going to be helpful if you're working with a team. So for example, you're working on a project with many people using SolidWorks at a time. You want to have everyone on the same page as far as their document settings. That just makes it a lot easier to combine and do an assembly and work on it if you're switching between people. The way you do that is when you make a new part, you're greeted with this dialog box, new SolidWorks document. You've got a tutorial where you've got basic parts, assemblies, and drawings, and then you have templates. Now, I have a few templates that I've made that change the precision of what you see here. So I'm going to open the default one, part, and you can see the difference. First of all, the background is this gray. You can change the background in this appearance tab at the top. I prefer plain white because it's just cleaner. If you want the 3-point faded, get a little bit of sense of perspective, you can do that as well. But more importantly for me is the dimensions. Dimensions by default are only 2 decimal places, and if you're working with high precision parts, that's not usually acceptable. So you can go up to the options tab up here, document properties, dimensions, and then you can change your primary precision to be whatever you'd like to see. If I want to see 0.123 decimal places after the decimal point, you can do that. And then all you want to do is save that as, and instead of a part, you want to choose part templates. And then you can call that whatever you want, 3 precision. And then it'll save it in the same file that you would actually use to create your new parts. So now if I go to new templates, you can see 3 precision, and I can open that up and it'll automatically be whatever I want. You can also change things like your material property, or if you have a modular design, you can have that as your template. You can really do a lot with this feature. Okay. Next thing I want to talk about is section view. This is touched upon in E26, but it is very useful if you have a complex assembly or part and you want to see what the inside of it looks like. It can be sometimes hard to see what it looks like from the outside. So I'm going to go to the 1, 2, 3 block for this demonstration. So here we have the 1, 2, 3 block. It's hard to see what the inside looks like. So up at the top here in your view taskbar, this icon, the 4th one, is section view. And with this, you can choose a plane, and then you can cut the model in half and see what the inside looks like. So I'm going to move it to right there. If you hit OK, then you could see what it looks like if you had taken a section off of this 1, 2, 3 block. this is really useful as well. Now, you can turn it off by clicking the button again, and this doesn't permanently destroy the model or anything, but allows you to just kind of look inside. You can also angle it however you'd like as well. Okay. Next, I want to talk about simplifying holes, and I'm going to do a demonstration for this in just a minute. But when you're making a part, a lot of people when they're first beginning use the extrude cut tool to make holes, and this is great. It works, but there's a faster and easier way to do it that allows you to get more precision and more detail in your part, and that's Hole Wizard. So Hole Wizard allows you to use standardized sizes of drill bits and taps in order to make consistent holes in your components. I'm going to show you a demo, and we're going to make the 1, 2, 3 block together. It'll be relatively quick. So I'm going to use the high precision part that we just talked about. And now I'm just going to make a simple 1 by 2 by 3 cube. So S shortcut, I'm going to use a center rectangle. Like I said, you want your parts to be symmetric about all the axes whenever possible. So 2 inches by 3 inches. And we're going to go for a mid-plane extrusion here of 1 inch. And then when you hit OK, it's symmetric about the planes. And if you want to check, you can just select the planes and click Show. And then you can actually see where they are relative to your part at any given time. Okay, next up, we need to add some holes. 1, 2, 3 blocks are very easy, in that they're just a block with holes. I'm going to use the Hole Wizard tool up here. And what this allows you to do is just select a face and drop points for where those holes need to be. You can customize the type of hole, and then it's pretty much finished. So I've already customized the hole because I just made another 1, 2, 3 block, but all I have to do is select where I want these holes to be. Now I could click 15 times and then align them, or I could use the linear pattern tool, which is what I'm going to do. So normal 2 makes it a lot easier to see by removing unnecessary detail. I'm going to make it a 1/4 inch away from these edges. Another time-saving shortcut is if you're adding a dimension and you want it to be the same value, you could just double-click on that dimension. It'll jump to that value. Okay. Next, linear sketch pattern. To select the number of units or the entity you want to pattern. I'm going to pick this point, and then you can make however many you want in whichever direction you want. So I'm going to make these points 65 away from each other. If you want to change the direction, this reverse direction button is what you'd use there. Okay, now we have the hole's position. And if you go into the tap section here, you can choose what type of hole you actually need. So you have different options. You can have counterbores, countersunk holes, tapped holes. And the reason why this is useful is because you, instead of having to find the tap size that you want to put into a part, you can just pick what size thread you want. If I want 832 threads, then there it is. And you can pick the size of the countersink as well. Okay, so 1, 2, 3 blocks are 3/8 16 holes, and countersinks are set up properly, it looks like. So you hit OK. And then there's a lot more of the work done than if you had used the extrusion tools. They're already countersunk and the right size for your tap. I don't think I need to go through the rest of the part because it's relatively simple, just the same thing again.
Where's the Hole Wizard?
Yes, the Hole Wizard is in the features toolbar up here. In the middle section where my mouse is the Hole Wizard tool. And also, if you ever need to look for any tool, if it's not in the same place, on the top right is the search bar where you can type in whatever you're looking for and it'll bring up options that'll help. Now, can you guys still hear me? My internet connection is unstable, it says. All right. Well, you can also choose to search whether you want to look through commands or SolidWorks Help. By default, it's SolidWorks Help, which is almost useless. So I switched it to commands. It's much more useful. Okay, next up, I'm going to talk a little bit about assemblies. I've made an assembly that we can use to demonstrate a few things here that uses some of the body features we were talking about earlier. And I'm going to go through that step by step. I'm not gonna go and make another one because it'll take longer than the amount of time we have, but I'm just gonna open it up. So this is the finished assembly. This is just a camshaft with several cam followers riding upon them. And this was all actually created from one part. So even though it says it's a whole bunch of assemblies, this was actually all created from one part. And I'll show you how that was done. And here was the part, the aforementioned part. Now I'm gonna go step by step through how I made this. So I started off with just half of the camshaft. I knew this was gonna be a symmetrical part, so all I need to do is do 2 of these boss extrusions for your cams, and a cam is something with a different diameter so that something can ride upon it and choose a height. And then I just mirrored that among this central plane. And now I've gotten, let's say this is the part I needed to make. It's essentially finished. Next step is to make a frame around this. This was an extrusion from this sketch here that I've made on the front plane. You can customize this, and everything else that follows is actually dependent upon these dimensions. So if I make this a little bit smaller, and the model will update accordingly. Now there's a problem here in that these two intersect. They both have material in the same place. We don't want that. So with the cut extrude tool, you can make all of your features only apply to specific bodies as well. This is something that's really useful. In the feature scope selection on the bottom left of the feature manager here, instead of selecting all bodies, which would cut through the central shaft here, we don't want that. Just choose selected bodies, and then you can choose whichever ones you want it to affect and which ones you don't want it to affect. And also, I didn't mention this, but when you extrude this one, you don't want to merge the solid. You don't want to merge it with the other body. You want to make sure it's extruded as a new body. So at this point, you have your central shaft and your extrusion. Okay. Next step was to create these wells at the top. These were just extrusions of O-rings, essentially, and then cut through to see a gap. These are the guides for the cams, or for the followers to actually slide up and down on linearly. Now, same process as before. We don't want to do that again on the other side just because it's kind of a waste of time. Even though for this instance, it actually wouldn't have been, it's just a single plane. It allows you to kind of cut some corners wherever possible. Next up is adding this little peg that kind of goes up and down here. Simple extrusion, and the rest of it is just making it round on the tip. And this is where the magic happens. We have all these bodies at this point. We have one here, and one here. And that's where we want to use the save bodies command. If I roll forward before it happened, what you want to use is, you can just go and search for it. Save bodies right here. I have no clue where it is in the toolbar. But then you can choose each body and you can choose where you want to save it. And you can change the name of the file. Say I want to name it, I don't know. You get the idea. I've done it already. It'll actually break the assembly, I think, if I do it again. But that's how you can take the bodies and put them into separate parts. Now they're saved as split parts, and that's slightly different from your standard SolidWorks part in that it's a derived part, essentially. What that means is it depends on the dimensions that are specified in another file. So if I open up any of these bodies that I have saved, okay, I've got a question. Does making a subassembly like this as a single part improve the processing time, decrease commuting requirements, SolidWorks for a larger assembly, or no significant difference? If you're in a larger assembly and you have many components dependent on one file, I don't know if it'll create a significant difference, but I would think that having everything depend on the same place wouldn't have a significant amount of time on computing requirements. So I actually don't know in full depth. I know it makes it a lot simpler from the user's perspective, though, because if you want to change around this assembly, every dimension that I could possibly need to tweak is just within reach right here. I can edit the sketch of this camshaft, and everything else will update accordingly. Okay. All right, so then once I've saved these parts, all you have to do is insert those into a new assembly, and I'll do that again. So from templates, make an assembly. Now, when you insert components into an assembly, there's a few things to keep in mind. The first component that you insert will be automatically fixed in place. And this is so that you don't have an assembly that's dependent on random positioning. I'll show you what I mean by this in just a second. So I'm going to insert the shaft to start. So I can click anywhere to put it at a unspecified position in space, or if I just click the check mark, it'll put it at the origin automatically. And you can see next to the name of this shaft, there's an F. That means it's a fixed component. And that means that I can't click and drag it. This component is fixed, it cannot be moved. That's good if we're starting off with an assembly. We don't want other components to be moved. But if I'm doing the same thing again, if I am putting in the shaft housing, for example, I do this, I don't really want the shaft to be fixed anymore because I want the shaft to be able to rotate. So you right click on it and you float the component in order for it to be able to rotate. And now it's free in space, I can do whatever I want with it. In order to make the assemblies depend on mates. Mates can be used by clicking on a surface, going into this flyout toolbar and clicking the paperclip to mate it. And there's several different types of mates that are useful within assemblies. General rule of thumb is to not strictly depend on any mates that are not physically possible. What I mean by that is there's this thing called the width mate that allows you to situate a component perfectly centered between two other components. This is great in theory, it allows you to center things, and it's good for lining up components, but you can't actually do that in real space. You can't force something to be in the center. You can force a shaft to be coincident with a hole, with a coincident mate or a concentric mate. And that's just by a bearing surface, for example. You can also force this surface to be flush against this surface with bolting it together or locking it together with nuts, or for example, if you had a clip on the inside diameter here, that would stop it from moving left to right. So what I've just done is I've mated the face here side to side and then the axis concentric with the hole. So now this shaft can rotate. And the next thing I'm going to talk about is design verification in assemblies. So there's this tool called the Move Component tool. You can click and drag, first of all, to move components around, assuming they're not fixed, or you can hold right-click to rotate components. Bad example because the mate is currently held in place. But if I have this component free, if I hold right-click, it'll rotate the component in place. Left-click will slide it in place. Okay. To hide these mates, I suppress them. Suppressing components actually isn't taught in E26, I don't believe, which is surprising to me because it's an extremely useful tool. Suppressing components tells SolidWorks to pretend that feature or that item does not exist. So if you suppress a mate, it'll say, okay, I'm going to pretend that I don't see that. And then you can kind of move around as you need. You can do this with mates, you can do this with components, you can do this with sketches. Any feature that you have within the feature manager over here, you can do, you can suppress.
Did you make the plane of the end of the axle coincident with the box face? Is that what you did there?
I did, yes.
But it still lets you move it around as long as the planes stay, as long as they stay within the same plane.
Yeah, so good question. If I just hide this one or suppress this one, that's interesting. Oh yeah, so this is what I was talking about. It looks like I'm moving it, and that's because perspective is off. Now, what actually happens is if I rotate it, you can see that it's actually very far away. And it's very easy to get lost and not know where your components are. And this is what I was talking about where the F tool comes in handy. If I press F, I can see, oh, what the heck happened here? And I can see exactly where the component is, and I can move it back to where it should be. And I'm going to unsuppress this so it looks like it's actually in the right place. If you want to turn on perspective, you can do that. In the view dialog in the TV box on the right side, there's drop-down menu. You can click on perspective, and then things actually look like they vanish as they go off into the distance. And then you wouldn't have that issue. Okay. I've talked a little bit about this, but I'll go through the slides. Left click drag moves a component, right click drag rotates a component. That's useful if you're trying to orient things within an assembly. And then the move tool allows you to do a little bit more than that. So with this cam in place here, it's will become pretty clear that as I spin it, it will hit this top surface, I believe. Maybe it won't actually, but if it were to continue spinning, it would get very close, and I wouldn't be sure if it would actually hit the surface. So just to make an even more clear example, I'm going to change the dimension of this extrusion. If you want to change the dimension of any feature, you can double click on it, and it'll show you the relevant dimensions used to make it. So instead of going into the sketch settings, you can just change it from the start by double clicking on it. So I'm going to change this to 0.75 inches, make it too small on purpose. It won't update yet. You have to rebuild the assembly to do that. There's a few ways to rebuild the assembly. One of them is by going to the top left part of the screen, rebuild, there's a traffic light button. You want to right click that and it'll show the change in dimension. The shortcut is Control B. So if you need to rebuild an assembly, just Control B will rebuild it. Okay, now that I've done that, I can go to the assembly, and as it was saved as a derived part, it'll automatically update. And now you can see that there's no space. So this is some tight clearances. If I wanted to see how close it was, what I can do now is use the Move Component tool, and then turn on collision detection and stop at collision. What that means is when I'm dragging this, as soon as it hits the top plate, it'll stop moving. That can be really useful if you're in tight clearances and you want to see exactly where it'll touch. This can also be coupled with section view if I want to see what it looks like at the point where it's actually touching. So, okay, I can see that it touches at that surface, and I can even measure how far away from that edge it is. That can be very useful in some designs. Okay. Next thing I'm going to talk about is copy with mates. So if you have a lot of components to insert and put in specified locations, a good way to do that and save time is to use the copy with mates feature. So I'm going to insert the follower that we were using to ride on this cam. This needs to go right about here, let's say. Now this one, you will have to make the first one in place. It needs to be concentric with this shaft. And that's actually about it for now. Let's just say that. So I could do this again. I could insert another component and then mate it in place and do it again. Or I could use the copy with mates tool. How you do that is you right click on the component, copy with mates. This is the shortcut I was talking about. If I right click right now, it'll go to the next step. So this, now all I have to do is click where I need to put the new part and then right click and I can go on to the next one. And this saves a lot of time because you can just insert 4 components that are already mated in place exactly where you need them, just with the copy with mates tool. And to exit out of that, you don't press the green check, you actually press the X. And now I have parts where I need them. They can slide up and down. Let's grab the front view, make it a little clearer. And I still have perspective on, which is why this is confusing. They can slide up and down as such. Now I'm going to change the size of this part once more, just so I don't have the interference, because I need that for the demonstration. I'm going to make this back into 1 inch. Control B, and it rebuilds. Back to the assembly. And now I'll show you another step, which is physical dynamics in the Move tool, something also that can be useful. If I have all these pegs and I wanted to see how far they will actually move with the simulation when the cam actually turns, you can check that in SolidWorks. How you do that is you use the Move tool within the assembly dialog box or command manager tab, move component, and then turn on physical dynamics. And what this does is as a component moves, it will actually force other components to move. So you can see what this looks like. It actually pushes the cam parts up. Now they won't fall again because there's no gravity simulation here, but this can be helpful if you're in an assembly where there's parts moving against one another, how they will actually interact when they hit. It's a very useful thing to do, especially if there's like a lock. If it moves past something, it locks into place, you can physically tell that it won't be able to move. Okay. A lot of the other time-saving tips that we talked about also hold true in assemblies. So for example, mirroring components, you can, if I didn't want to go through and copy with mates all of those followers here, I could have copied them from these two. I could have just mirrored the position of these two among the center plane. There are some reasons why I didn't do that. For example, that would, I believe that would force them to move at the same time. So as this one moves, it would force this one to move as well, to simulate this essentially, which is not what we'd want. I mean, in this case, it doesn't matter because they would do that anyway, but not necessarily what you would want. You can also replace components if they are similar enough to another one. So for example, let's say I made a different version of this peg. I can actually do that. If I open up the follower here, let's say I want to make a version with a different tip. I can do that. I can save this as a copy. I can make whatever changes I need to the part and then just replace the part within the assembly. So I'm going to just make a little bit that sticks up here. Completely arbitrary for this point, but now if I save this, what you can do is go into your assembly here. Right click, and then there's an option to replace a component. Maybe it's in the feature manager actually. I want to replace this one and replace components right there. You pick follower 2, and then it'll automatically replace it with the mates still in place. So now this one can still only slide up and down, but it's a completely different part. That's something helpful if you want to make different versions of a different part and see what each one looks like side by side. Okay, that actually goes through everything that I wanted to cover in this presentation. We have a little bit more time though, so I'd like to open this up to if any of you guys have questions or want to learn more about anything specifically. So thank you guys. Any questions?
Do you have any experience with Solidworks CAM, like the manufacturing aspect?
I don't, unfortunately. I use Fusion 360 CAD or CAM just because it's been more applicable for the CNC machines that I've used. I've only used the ShopBot CNC at Jacobs actually, and the laser cutters, but those are a different procedure entirely. So unfortunately not.
Can you explain why you use the saved bodies feature?
Yeah, absolutely. Now that was in this assembly, right? Let me open that up. Because I have time, I'll actually just go through doing that entire step. The reason why you'd want to use the save bodies feature is instead of making a whole bunch of separate parts from scratch, you can make every single part within one part, essentially, if that makes sense. Instead of going through and making the camshaft and then making the enclosure and then making the follower, I can do those all within one place, and then I can change all of those dimensions at a time. If I wanted to change the size of this, I can make it 2 inches or whatnot. And rather than having to go through into every single part that depends on that dimension, so let's say I had, a stand that it was sitting on that needed to line up with it, I could change that all in one place as opposed to changing each component separately. The reason why I use save bodies is it creates a linked part. So when I change one dimension, that'll carry through. Does that answer the question?
Yeah, thank you.
Yeah, of course. Okay, I have one other thing that I wanted to show that actually also demonstrates that point really well. This is a personal project that I was working on. It's a bookshelf, sure, for my apartment. Okay, and because I deleted the file, of course, it's going to throw a whole bunch of errors. I don't need to worry about that. Another important part of SolidWorks is being able to trace your errors. Okay, I'm just going to open the file that I'm looking for rather than having to sort through all the errors that result there. That's something to be careful about. If you don't go about this if you do make a mistake and you delete one of the crucial components at the wrong stage, then you could have some errors within the assembly. So you just want to make sure you keep track of where your opponents are and what you're doing with them. Let me open up the file I'm looking for, though. Okay, so this is a bookshelf that I'm designing for my apartment based on my favorite artist, P.A. Mondrian. Here's what it looks like with color. And this really shows the advantages of using separate bodies and saving them afterward, is because what I can do is make every single component that I want here. So there's 16 solid bodies, and then I can just have them all in place depending on one sketch. So for example, they all depend on this one sketch right here. If I edit this sketch, the entire thing will update. If I make this 17 inches versus 16 inches, unless I did something fishy, it should all update accordingly. I did something fishy. Okay, never mind. What you're aiming for, though, when you design these things is to make it so that everything is not dependent on external dimensions, but rather on what other features preceded it. I'm just going to undo what I just did there. There we are. So you can go through and make this whole thing as one part. Right now, it's just one solid body. And then using the intersect tool, like I talked about earlier, there's actually more to it that I didn't touch upon, which I can go into now. The intersect tool, along with planes, can allow you to cut exactly where you want. So what I did here is I created a plane, and I'll go through how to create a plane as well. And this shows how I wanted to divide the part. So this plane here, using the intersect tool, I was able to divide these bodies separately from the rest of the assembly. And the end result, I'll just go through the bodies that I have in this assembly, is that I've got this back panel, all of the back panels here actually. And I've got the mounting positions, which are not as relevant for this demonstration, but. And then I have the separate bodies of the bookshelf. So if I was actually making this, what I'd want to do is make this side bit and then attach that to this central bit right here. I guess the central bit would be this, this, and this. I'd make this first, and then I'd make this and add that on, and then I'd make this and add that on. And that allows you to keep track of what you're doing at the same time. If I'd done this the traditional method with making separate parts for every component the way that they would be made, it would take me a lot longer because I'd have to constantly reference my initial sketch, and that's just kind of a pain. Okay, any other questions? All right, wonderful. If you joined late and you did not fill out the form in the chat, I'll send it again. There is a form in the chat, and I'll send the recording out as well if you fill out the form.